In this video, I am going to discuss about translating a function y is equal to x square to get to negative 1/2 times x plus 1 whole square minus 3. We start off with the function y is equal to x square and the vertex is at 0, 0. Let's label the vertex always so that we can keep track of things. Now we are going to translate this function or shift it vertically or horizontally or reflect it to get to the final function, which is this. Now let's start off with the easy one, x plus 1 whole square. Look, it's an inside change. You are adding 1 to inside. That means it's going to take this function and move it to the left by 1 unit. So the graph of the new function is going to be at negative 1, 0. Note, if you're adding inside the square or inside change, when the inside change is addition of a positive constant, is going to move the function, is going to shift the function or translate the function to the left by that many units. Okay, in our case it's 1, we added 1, so it's going to take the original graph and it's going to shift it to the left by 1 unit, and the new vertex is at negative 1, 0. So let's call this one my y1, which is going to be x plus 1 whole square. So we have this one. Now I'm going to take this x plus 1 whole square and multiply it by 1/2. So the effect of multiplying it by 1/2 is this. Basically what it is doing is saying that the original function, this one, is gonna go up by half as fast. So that means it's gonna flatten. So if you sketch it, it's gonna look like this. It's gonna be a flattened parabola. The vertex is still the same. It stays the same way, like this. So let's call this my y2. My y2 is equal to 1/2 times x plus 1 whole square. So we are there right now. Now I'm going to take this y2 function and multiply it by negative 1. The effect of multiplying it by negative 1 is reflecting it about the x-axis. So this brown looking graph is going to be reflected about the x-axis. Once again, let me remind you, multiplying it by a number between 0 and 1, multiplying this function or this one, doesn't matter which one you do, by a number between 0 and 1, between 0, let's say you multiply by k, which is between 0 and 1, is going to flatten the graph. That means it's going to stretch it horizontally, so it looks wider. The effect of this multiplication is that the function goes up slower. If the function goes up vertically slower, obviously it's going to look flatter like it does here. Now we take this y2 and multiply it by negative 1. So let me use a different color. But multiplication by negative 1 is going to have the effect of reflecting it about the y-axis, about the x-axis. So my new function, let's call it y3, is going to be negative 1/2 times x plus 1 whole square. Now we are up to this point. Now the last step is subtracting 3. Now you have to keep in mind, subtracting 3 from this y3 is an outside change. We are not making any changes under the square. So remember, outside change makes the graph move either up or down, or make the graph moves vertically. Once again, the outside change makes the graph move vertically. So in our case, we are subtracting 3. So we are going to take this graph and we are going to move it down by 3 units. So my new vertex is going to be at right here, let's say 1, 2, 3. So it's going to be negative 1, negative 3. And it's going to be the exact same graph. So this and this is the same. Only thing is that I shifted it down, or I moved it down by 3 units. So this is my final graph, which I call y4, which is also the y, right? Y is equal to negative 1/2 times x plus 1 whole square minus 3. This is how you'd start off with a simple function x square and then translate it horizontally, vertically, and reflect it to get to a final function such as this. By the way, this concept, I have given this example using the x square function. This applies to any function. Okay, this will apply to any function. If you just have to follow the basic rules. I used x square because it's very easy to see. That's the only reason. I hope that this discussion was helpful. Thank you very much.